Hello everyone, myself Lokesh Dadoriya, and my topic of this presentation is constant velocity joint for the front axle shaft. I want to start with the introduction part. Constant velocity joint allow maintaining the same shaft rotation speed. Constant velocity joint facilitate the steering of the vehicle by minimizing the stresses which would compromise the transmission time. Constant velocity joints are also known with name of homokinetic or CV joints and allow a draft shaft to transmit power through a variable angle. The transmission also happen at a constant rotation speed and without any appreciable decrease in play of friction. Usually, constant velocity joints are protected with the aid of guitar filled with molybdenum disulfide grease and rubber wood. Another interesting feature connected to this joint is that whatever the operating angle of constant velocity joint, the rotation speed of the output shaft always remain the same as that of the input shaft. Here are the six most common type of the CV joints used in vehicle. The Zappa outer CV joints is the most common joint type. The design of this joint enabled the transmission of a power through six spheres which were positioned between the outer race and inner race. These spherical balls are secured in their location with the help of small windows inside of a cage assembly. This assembly is what goes between the outer race and inner race. Second one is fixed and plunge joint. A plunge joint is an inboard joint within front wheel drive application. A fixed joint is an outboard joint. A plunge joint not needed for these two if at least one of the joints can do the job properly. Also, it is crucial that outer joint can tolerate bigger operating angle which are necessary for the steering. Third one is plunge joint, tripod, and ball type. These type of joints have either a tripod or central drive. The tripod or spider contain three turnions which have needle bearing with spherical roller. They also have an outer housing. The joint on some tripod have a closed outer housing, causing the roller track to be completely inside of it. There are also joints which have an open tulip and outer housing, which had their roller track machined out. The most common use of the tripod joint is as front wheel drive inner plunge joint. Fourth one is tripod joint. The interior end of the drive shaft has a tripod joint. This allow power to transmit it regardless of whether there is angle shifting. The feature of the tripod joint include a three-legged spider with mounted on barrel-like rollers. These go into a cup which has three grooves that are connected to differentials. These barrel-like rollers have 120-degree mounted to each other and have the ability to slide forward and backward on its track within the tulip. Fifth one is tripod joint fixed. Front wheel drive application will sometimes use a fixed tripod joint as the outer joint. The outer housing has the trunnion mounted on it. Then the input shaft has an open tulip in which three roller bearing will turn against. The joint is held together by a steel spider that lock it. Sixth one is inboard joint and outboard joint in drivetrain of front wheel drive vehicle. Every half shaft has two CV joints. The inner joint is one closest to the transaxle and outer joint is the one closest to the wheel. In rear wheel drive vehicle which have independent rear suspension, the inboard joint is one closest to differential while the outboard joint is one near to wheel. Here you can see in figure 1 tripod joint. Tripod joint is a type of CV joint which absorbs the horizontal and axial movement of engine transmit the drive speed of the drive shaft. In figure 2 You can see drive shaft. A drive shaft is a mechanical component for transmitting torque and rotation, usually used to connect other components of a drivetrain that cannot be connected directly because of distance or the need to allow for relative movement between them. Figure 3 shows hub. Hub is driven by shaft running from the final drive. The shaft has flexible joint, usually constant velocity joint, at each end to allow for steering swell and suspension movement. In next figure, you can see CV boots. Constant velocity joints are covered by rubber or plastic boots, known as a CV boot or drive axle boot. These parts are responsible for keeping the joints lubricated and preventing dirt and water from getting in. In figure 5, so the constant velocity joint. Rizapa constant velocity joint is defined as a self-supported constant velocity joint that contains a outer and inner race connected through balls positioned at a constant velocity plane by axially offset curved grooves. The balls are maintained in this plane by a cage located between the two races. The design of this joint enabled the transmission of a power through six spheres which were positioned between the outer race and inner race. These sphere balls are secured in their position with the help of a small window inside the cage assembly. The assembly is what goes between the outer race and inner race. Figure 6 shows the component of Zappa velocity joint. Start with the housing, then circlip for a for is type of a fastener consisting of a semi-flexible metal ring with open end which can be snapped into place into a machine groove on a dowel pin to permit rotation. Then we see an inner race here and case, then balls, and ball is fitted inside the case and case is mounted on inner race. Then we see clamp and boot, which clamp help to lighten the boot. Then finally shaft. Shaft is here. Here we can see the assembly of Formula Society of Automotive Engineering car of IIT Delhi, Team Accelerator, which is designed by one of my team members, Shabi Malik. In this CAD model, we can see the tripod bearing which is mounted on both the end of drive shaft and hold with the help of circlip. Here you can see the circlips and one end of the drive shaft is inside the hub. Hub and gearbox are connected with motors. Here there is a gearbox and this is a hub and torque from the motor transmitted to the wheel with the help of these joints. Here we can see the manufactured assembly of CV joint front axle shaft. So here we can see the assembly of the Zappa type CV joints in wheel side and tripod type in differential side. Now I want to discuss the working of CV joints. The CV joints are the primary component that allow drive shaft to do their job. They work in harmony to transfer rotation power from the transmission to the car wheel efficiently, to turn the car wheels at a constant speed regardless of operating angle. The constant velocity joints are mainly used in front wheel and all-wheel drive cars. Rear-wheel drive car with independent rear suspension typically use CV joints at the end of the rear axle hub shafts. Constant velocity joints are protected by a rubber boot known as the CV gator. Each CV joints include an inner and outer joint. Now I want to compare tripod joint and Zappa joint. Tripod CV joints generally provide rotational allowance, Zappa provide linear allowance. The tripod joint is provided at the gearbox assembly and Zappa at the rotor or upright of the wheel. Tripod provide rotational allowance and gives a linear allowance. Now I want to discuss advantage and disadvantage of the CV joint. First, let's start with the advantage. These joints are capability to work at greater angle, smooth behavior, and quieter. But using of these CV joints had some disadvantage also. These joints are little expensive. The presence of sliding friction and that the joint is not 100% homokinetic, that is, it does not completely provide constant velocity. Without this feature, the joint is not optimal, leading to energy inefficiency, vibration, noise, premature wear, which shorten its lifespan and that of the surrounding bearing. Now we will discuss the problem we face due to the use of CV joints. Usually, constant velocity joints are protected with the aid of gaiter filled with molybdenum, disulfide grease, and rubber boot. Usually, constant velocity joint can wear if cracks and split allow the entering of contaminant, contaminant and leaking of grease. This way, the friction part cannot get a proper lubrication and end up being damaged by minor particle penetrating the part. At the same time, water can also cause metal components to rust and corrode. That's why normal uses of constant velocity joints must take into consideration the regular wear of boots normally appearing as small cracks close to the wheel. The vibration and up and down motion are more redundant. Finally, external factors such as packed snow, stones, or uneven and rocky paths can also cause cracks and tear in areas that are located close to axle. Now we will discuss the symptoms of CV joints failure. Bad boots are not the only thing we need to look for. We also need to listen for noise or complaints that might indicate a CV joints problem. This include popping or clicking noise when turning. This almost always indicate a worn or damaged outer CV joints. A clunk when accelerating deceleration or when putting the trans axle into drive. Noise comes from excessive belly in inner joint on front wheel drive application. A vibration when accelerating may be caused by plain inboard outboard joint, but the most likely cause is a worn inboard plunge joint. A vibration that increases with speed. This symptom is rarely caused by failing CV joints. Now we come to the conclusion part. The rubber boot is the component of the drive shaft assembly of the front wheel car that need the utmost care. If it is safeguarded, then the drive shaft is protected against premature failure. From comparison, it is also evident that advantages of the front over rear wheel drive car are enormous and quite sensitive, while the disadvantage of rear wheel drive outweighs that front wheel drive. Majority of the modern car are mostly front wheel drive. Thank you.